Now that we know a little bit about the solar wind, we need to begin to learn about the sun itself in order to learn what types of solar events can change the solar wind and other energetic aspects of the solar system which can affect Earth. We will begin by looking at the important layers for those events, the ones important for what we call space weather. Until the GOES-R launches in 2016, the Solar Dynamics Observatory is the best means of looking at the different layers of the sun. Looking mostly in extreme ultraviolet and the X-ray spectrum, the SDO as it's called monitors the sun while in orbit above the Earth. Looking in 94 angstroms of light, one camera detects the extreme UV and X-ray energy from solar flares, an important element of space weather. Like many of the cameras aboard the SDO, this detector is capturing ionized iron and assigning color to the particles detected. A number of cameras can show us aspects of the solar atmosphere, the corona, including in 193 angstroms of light, arguably the best all-around way to watch our star at this time. The camera looking in 304 angstroms captures ionized helium and can present impressive detail of the massive solar events that end up being important for humans living on the Earth. Using helioviewer.org, a free website that lets us create downloadable videos from the SDO and numerous other satellites, includes the ability to combine different wavelength detectors. Right now, we're looking at a combination of the 171 angstrom detector, another ionized iron extreme ultraviolet camera, faded and appearing as loops going up into the corona, and below that is a near-surface layer or photosphere detector, looks for ionized carbon, and in the far ultraviolet spectrum. We also detect the continuum of ions here, just like in the solar wind. There is even a special magnetic imager on the SDO satellite. It lets us see right down to the sunspots. These cameras utilize the visible spectrum, and every particle you see here is neutral iron on the sun. We can even detect the polarity, the magnetic force of these particles, and especially sunspots. Those loops we saw in some of the ionized iron detectors, like this 171 angstrom sequence, only connect to the sun at oppositely polarized sunspots, leaping way up into the corona. Recently, a specialized satellite called IRIS was launched and began using its super zoom capability to bring us unprecedented images of the sun close up, revealing never before seen details of how our sun works. Certain cameras have specific specialties. The 211 angstrom imager reveals coronal holes, those dark patches you see. There's not really a hole in the sun, just a portion of the atmosphere where you won't find those magnetic loops, but open fields that send the charged particles out into the solar wind at a faster pace. The absence of those particles registers black by the detector. High above the surface, and often above much of the corona, we can see plasma filaments defying gravity, suspended by magnetic forces, and another important element of space weather, as they can sometimes release into space. We've mentioned space weather a number of times now. In the next episode, we will begin to explore what space weather is and introduce why it is so important for the future of our planet.